These are the three most missed questions on the Evaluating Functions test. Number 11, number 5, and number 7. We're going to look at each one at a time. On number 11, we need to compare properties of these different functions. One shown as a graph, one a table, one an equation, and one simply giving the slope and y-intercept. We need to find the slope of each of these equations first. To find the slope of a graph, we're going to look for rise over run. Since from one point to another it goes down 4 and over 1, negative 4 over 1, which equals negative 4, is the slope. On a table, we want to look and see how the y value is changing. Since the y is going up 3 each time, that means our slope is 3. On an equation, we want to look at y equals mx plus b, remembering that the number with the x is always the slope, in this case negative 2. And for our last function, number 4, it tells us that the slope is 5. Now, if we want to see which function is the steepest, we're going to look for the slope that's the farthest from 0. Remember, if the slope is 0, it's a flat line, which is not steep at all. So the bigger the number, whether positive or negative, then the steeper the slope. Since 5 is the largest number for the slope, number 4 is the function that is the steepest. The third question asks which slopes are greater than negative 3. In this case, we want to think about a number line. Anything to the right of negative 3 on the number line is going to be greater, in which case we would have functions 2, 3, and 4 because their slopes are 3, negative 2, and positive 5. To answer the second question, we have to find the y-intercept. The y-intercept is where the function crosses the y-axis. The first function on the graph crosses at 4. Remember, it's also where the x value is 0. If we look at a table and see the point where x is 0, the y number is the y-intercept. So function 2 has a y-intercept of negative 1. In the equation, it's going to be the number that does not have an x. So negative 3 is the y-intercept of function 3. And function 4 tells us that the y-intercept is 2. Since we want to see which function has a graph with the y-intercept farthest from 0, we're going to compare 4, negative 1, negative 3, and 2 to see which is farthest from 0. Since 4 is the farthest from 0, function 1 is our answer. On question number 5, we need to write the equation through the line. We have to figure out the slope and the y-intercept in order to write our equation. We start by finding the slope by doing rise over run. Since this goes down 2 and over 6, negative 2 over 6, which is negative 1/3, will be our slope. The y-intercept is going to be where the line crosses the y-axis. Since this one crosses halfway between 1 and 2, we could estimate that maybe it's 1.5, but to be sure on fractions, we always want to plug it into the formula. We're going to choose one of the points, which gives us an x number and a y number, and use our slope, and we can plug them into the formula y equals mx plus b. Since the y number is 3, the slope is negative 1/3, and the x number is negative 5, we get the function 3 equals negative 1/3 times negative 5 plus b by placing each number in the spot it goes in that formula. The y number goes for y, the slope number goes for m, and the x number goes for x. We haven't put any number for b yet because that's the y-intercept and we don't know what it is. In order to find that, we're going to have to solve this equation for b. First by distributing, negative 1/3 times negative 5 equals positive 5/3. And then by doing our opposite operations. The opposite of adding 5/3 to b would be to subtract 5/3 on both sides. And since 3 minus 5/3 is 4/3, that's our y-intercept. Now that we know our slope is negative 1/3 and our y-intercept is 4/3, we can write our equation. Remember, the slope gets the x, and the y-intercept does not get the x. So we have y equals negative 1/3 x plus 4/3. The last problem, number 7, wants to find the initial amount and rate of change for the function given in the table. We want to start by seeing how much water was there at the beginning. Since every minute drops 4 minutes, we would want to continue back 4 minutes until we reach 0. The amount of gallons drops 44 each time, so we would continue subtracting 44 until we reach our 65 gallons at time 0, which means it started with 65 gallons. Just find the pattern and continue it. Now we need to answer the question about the rate of change. As the time is increasing, we're going to the right, which means we need to relook at our values and see as we head to the right that every 4 minutes adds 44 gallons. So the amount of gallons is increasing as the time increases. Since it increases by 44 gallons every 4 minutes, we're going to divide 44 by 4 to see that that's 11 gallons per minute. So our answer is 11 gallons per minute for the rate of change.